Today we're going to be talking about redox reactions, also known as reduction-oxidation reactions. Definition of which are a reaction where certain atoms undergo changes in oxidation states. Here we can see that there's two different ways to undergo those changes. One is the substance that gains electron is being reduced. The substance that loses electrons is being oxidized. And the reducing agent, also known as the reductant, is the substance that is oxidized. The oxidizing agent, also known as the oxidant, is the substance that is being reduced. Note here that you cannot have reduction without oxidation and vice versa. These two get a little confusing, and we'll go into more detail on those later in the lesson. So let's use this redox reaction as an example. We got the dichromate ion plus the iodine ion yields the chromium 3 plus the iodate ion. So step 1, identify the oxidation number of each atom to see which gains electrons and which loses electrons. So for the dichromate ion, the overall charge is 2 minus. So we know that oxygen always has a 2 minus on the atom. And since there are 7 oxygens, it's a total of 14 minus on this oxygen. So we know that we need to have an overall 12 plus with these chromiums to get a 2 minus charge. Since we have 12 plus and we have 2 chromiums, you divide 12 plus by 2 and you get 6 plus. You add the iodine ion, which is 1 minus, that's a 1 minus charge, chromium 3 plus charge, and same goes with the iodate over here. You got 2 minus charge on the oxygen, you have 3 oxygens, which is a total of 6 minus on that oxygen. Since the overall has a 1 minus charge, we know that this iodine has to have a 5 plus charge to make this true. We go step 2. Use arrows to make it clear which substance loses and gains. So we go here, we see that the chromium right here is 6 plus, and over here it is 3 plus. So we know that the chromium gains 3 electrons to get to the 3 plus charge over here. And this over here, the dichromate entire ion, is known as the oxidizing agent. Here, the iodine ion, 1 minus, you can see that it loses 6 electrons to get to the 5 plus charge. This iodine 1 minus is the reducing agent in this thing. And you can see the little syntax right here, an E with a minus right above it, is known as electrons. Let's look at half reactions. Reduction half reaction is an equation for reduction that explicitly shows the electrons involved. So as we can see, the dichromate ion plus 3 electrons yields the the chromium 3 plus. This is the substance getting reduced, so we gains 3 electrons. And then we'll go through the steps on how to solve this half reaction. First step is balance. You have 2 chromiums right here, which means you have to have 2 chromiums over here. Because with just 1 chromium over here, it's only 3 electrons. Because we got 2, the electrons also have to double because of the mole ratio. Second step, add water to balance the oxygen atoms. As we can see, the dichromate has 7 oxygen atoms, whereas over here we have none. So we have to add 7 waters to balance the oxygen. Step 3 is add H plus to balance hydrogen atoms. So we can see right here from the water we have 14 hydrogen atoms. Here we can add 14 hydrogen ions to balance the hydrogens. Then 4, make one last check to make sure that it's balanced according to mass and charge. So you got 14 hydrogens, 2 chromiums, 2 chromiums, 7 oxygen. Let's look at the charge. You got 14 plus minus 2, that's 12 plus, minus 6 is 6 plus on this side. 2 times the 3 plus is also 6 plus. So we got it balanced according to mass and charge here. Now we look at the oxidation half reaction. So the definition is an equation for oxidation that explicitly shows the electrons involved. So we know that the iodine 1- got oxidized into the iodate plus 6 electrons. So we go through the same steps again. 1, we balance it. This is already balanced with 1 iodine ion, 1 iodine ion with the 6 electrons, and then we go to step 2. Add water to balance the oxygens. We can see that the iodate has 3 oxygens on this side, so to this side we add 3 waters, and then leave it at that. Step 3, we add hydrogen ions to balance the hydrogens. Since we added 3 waters, we need to add 6 hydrogens to the iodate side to balance that. And then step 4, make sure it's balanced according to mass and charge. You got 6 hydrogens, 3 waters, or 3 oxygens, 1 iodine, 1 iodine. Let's check the charge. 1 minus on this side, 1 minus, 7 minus, plus 6, that's 1 minus also. So now we go to combining half reactions. First, you want to make sure the coefficients of the electrons are the same on both sides of the arrow. So as we can see here, these are both the half reactions. We got 6 electrons here and 6 electrons here, so we're okay to add. You want to add on like each side. Pretend this is an equal sign. You add this side and this side. Here we go, step 2, add the sides together. So you add all these together on this side and all these on this side. And just like in an algebraic equation, you can cross out similar terms. So we have 6 electrons on this side, 6 electrons on that side, they can go away. We got 14 hydrogens on this side, 6 hydrogens on this side, we're left with 8 on this side. We have 3 waters on this side, 7 waters on this side, we're left with 4 waters on that side. And then you simplify. So you end up with 8 hydrogen ions plus a dichromate ion plus iodine 1- yields the iodate ion plus 2 chromium 3 pluses plus 4 H2Os. And this is your overall redox reaction. And then the last step is to make sure that you're balanced according to mass and charge once again. So we got 8 hydrogens over here, 8 hydrogens, 4 times 2. We got 2 chromiums, 2 chromiums. We got 7 oxygen. You got 3 oxygen here, plus the 4 oxygen from the water, which gives you 7. You got 1 iodine, 1 iodine. Mass is good. Let's check charge. 8 plus, minus 2, you get 6 plus, minus 1, you're at 5 plus. Here we got 1 minus plus 6 gives you 5 plus as well. You're good. You know that this is the correct redox reaction from the beginning equation we started with. The last thing is to make sure you know if it's in an acidic or basic solution. It is important to know whether or not your reaction is occurring in an acidic or basic solution. If it is acidic, solve the reaction as I have done, leaving it the way it is. If it is basic solution, add the appropriate number of OH- ions to the reaction. This means that you add OH ions to cancel the number of hydrogen ions that you have to combine to form water. You have to add the hydroxide ions on both sides, and then you complete your reaction and it's in basic solution. And that's all for redox reactions.